Imagine a revolution in satellite communications that's quietly taking place, challenging the status quo of massive, multi-ton satellites that have long dominated the geostationary orbit GEO. Portland, Oregon-based AscendArc is leading this change by selling its first small geostationary communications satellite to KTSat, South Korea's leading satellite operator. On September 4th, AscendArc announced its plans to deliver a spacecraft weighing less than 1,000 kilograms by the second half of 2027. This significant milestone follows a $4 million fundraising round earlier this year, aimed at entering the burgeoning market for compact, cost-effective alternatives to traditional GEO satellites. According to Chris McLean, AscendArc's founder and CEO, the satellite will boast a capacity of 500 gigabits per second, Gbps, rivaling the performance of EchoStar's Jupiter 3. Remarkably, this is achieved with a spacecraft that is approximately one-tenth the launch mass of one of the heaviest commercial communications satellites in GEO. McLean, a former principal engineer at SpaceX, attributes this performance to a proprietary antenna design that fits a 4.5-meter fixed reflector inside a Falcon 9 fairing, eliminating the need for complex and costly unfolding mechanisms. That allows us to have relatively low power and lightweight electronics, McLean explained in an interview with Space News. Growing competition in the small GEO market. While rivals like Astranis and Swissto12 designed satellites to fit into ESPA rideshare slots, which limits their antenna size to a few square meters and reduces capacity, AscendArc's approach offers a significant advantage. By focusing on larger antennas, AscendArc avoids the use of traveling wave tube amplifiers, TWTAs, the specialized vacuum tubes typically used to boost radio frequency signals. The payload is entirely solid-state, allowing us to use much lower-cost components with shorter lead times, McLean noted. This enables us to take advantage of manufacturing at scale, resulting in a payload that is an order of magnitude less expensive than conventional TWTA-based payloads. This innovative approach translates to bandwidth delivered at a cost per megabit up to 20 times lower than existing satellite constellations, according to AscendArc. The company positions its satellites at prices comparable to or below those of other small GEO offerings, and at about a quarter of the cost charged by legacy manufacturers like Boeing, Airbus, or Thales for medium-sized, high-throughput spacecraft. Design and longevity. AscendArc satellites are designed for a 10-year lifespan, compared to the 15-year design life of traditional GEO satellites. However, the company plans to load extra propellant into the all-electric propulsion system for KTSat, potentially extending the mission by 5 years. The trade-off lies in coverage. While large GEO satellites can serve a third of the globe from their geostationary vantage point, AscendArc satellites are optimized for continental-scale markets. McLean revealed that AscendArc is in discussions with other regional operators, as well as larger fleet owners and nations looking to enhance their sovereign capabilities. The startup is also preparing to compete for upcoming U.S. government missions, having secured a $1.8 million contract from the Air Force's innovation arm to develop high-bandwidth satellite communication technology. Regional focus and impact. KTSat's acquisition marks the operator's first high-throughput, data-focused satellite, set to join its existing fleet of around 6 multi-purpose broadcast and communication spacecraft. The satellite will target underserved communities across the Asia-Pacific region, where hundreds of millions remain unconnected or underconnected due to infrastructure and affordability challenges. The goal for KTSat is not just to compete, but to dramatically expand access to the Internet throughout the Asian region, KTSat CEO Young-Soo Seo stated. Over half of the world's population has very limited or no access to the Internet, and the primary reason is cost. Seo emphasized that the cost of terrestrial fiber has stagnated, often resulting in a negative return on investment for connecting remote or poor regions. And while some recent new satellite options have helped, they simply do not lower the cost enough to penetrate as far as needed. He added, ### market dynamics and future prospects. Other regional operators are also facing competition from SpaceX's Starlink broadband constellation in low Earth orbit, LEO. For instance, Thailand's Thaicom ordered a small GEO satellite from Astranis last year to provide broadband to remote areas in Asia. Thaicom 9 was scheduled to launch this year, but Astranis has not provided an update as it addresses a propulsion issue on one of its 4 spacecraft launched in December. To gain a deeper understanding of how smaller satellites are reshaping the economics of geostationary orbit, check out our feature on the GEO market transformation, along with interviews with the CEOs of Astranis and Swissto12. And this is the part most people miss: the impact of these smaller, more efficient satellites on global connectivity and the potential to bridge the digital divide in underserved regions. What do you think? Could this be the future of satellite communications? Or is there room for both large and small GEO satellites in the market? Share your thoughts in the comments.